Hey guys, welcome to this tutorial for unsolved. We are having unsolved for chapter number 7, oscillations, that is Gujarat board semester 2. First question is about obtain the equation for simple harmonic motion of the y projection of radius vector of resolving particle in case A and B of figure 7.22. Now we are having two figure, one is A and another is B. From this figure, just observe it closely. uh, we are having one rotating vector. This is actually a vector which is rotating, but at t is equals to 0 it is just starting its motion, circular motion, rotating motion. So we can say that initial phase, that is we are saying approach to it, that is 60 degree, and in radian we can say it is pi by 3, which is given to you. And in this case my initial approach, that is phi 2, is 90 degree at t equals to 0. But what is our standard equation? What standard equation for your displacement is equals to a sine omega t plus phi. Now let us see here. Time period t is given as 3 seconds. That means omega 1 is equals to 2 pi upon time period t, that is equals to 2 pi by 3. Now writing this equation for my first figure A, it is is equivalent to, see, amplitude it is given as from 0 to this point my distance is 2 centimeter. That means my amplitude is 2 centimeter to a sine omega t. Omega is 2 pi by 3 t plus phi. What is my phi? Phi is my pi by 3. Pi by 3. This is my first expression which I have got, and you can confirm the answer over here. Now for my second answer, I'll be having y2 is equivalent to amplitude. See, my amplitude over here is 3 centimeter, a sine omega. For my omega, my time period is given as 1 minute, so my omega 2 is equivalent to 2 pi by 1 minute, that is 60 second, that is equals to pi by 30. Pi by 30 t omega t plus phi. Phi is what? My 90 degree, that is pi by 2. But we can say that y2 is equivalent to 3. What is sine pi by 2 plus this theta? Sine pi by 2 plus theta, just see, sine 90 plus theta. Sine 90 plus theta is cosine of theta. So here sine 90 plus theta is cosine of my theta, that is pi by 30 t. That's why we are having these expression as a result. This is second question. In this question we are having a system of 3 springs. One is having spring constant 2k, another is having k, and my mass m is attached exactly over here. Now this system can be made more simplified like this. This is my mass, this is my one spring, this is my second spring, and they should be like this. It is having 2k, k and k as their spring constants. These two k's are actually in parallel, these two springs are actually in parallel with each other, and we know that effective spring constant for these two k's are k dash, that is equals to k plus k, that is given as 2k. So instead of drawing them separately, we can just draw one spring with the effective spring constant as 2k. Now these 2k and these 2k, these both are also like parallel with each other, and this type of system we have resolved, and we have also founded out the values of effective k, that is also given as k dash is equals to 2k plus 2k, that is equals to 4k. Now effective spring constant for this system is 4k. Now putting value of k, that is 2 Newton per meter, 4 into 2 Newton per meter will give me 8 Newton per meter, and that is effective spring constant k. Now we need to find out time period. Formula for time period is capital T is equivalent to 2 pi root of mass upon effective spring constant, that is equals to 2 pi root of mass is given as 80 gram, but we are having K in terms of Newton and meter, that are SI unit, but gram is not an SI unit, so we need to convert it, and 80 into 10 to the power minus 3 kg. So here 80 into 10 to the power minus 3 kg upon K effective, that is 8 Newton, and I'll be getting 2 pi root of 8 tens are 80, and that is 10 into 10 to the power minus 3, and that is 10 to the power minus 2, that is 2 pi into 10 raised to minus 1, that is equals to 2 into 3.14 into zero point 0.1, that is equals to 0.628, and that's what my answer is. Its unit will be second. Don't forget to write unit. It will cost you half of your weightage. Half marks will be straight away deducted from your total score if you are missing this second over here. So be attentive and be alert while writing answers. Always write units. Now next question. In this question, third, a spring of length L and force constant K is cut into two parts of length L1 and L2. So this is our spring, which is having a spring constant K, and it is cut down into two parts. One is this and another is this. One is having length L1 and another is having length L2. Here one relation is given to us, L1 is equals to n L2. We are going to use this. Now obtain force constants K1 and K2 respectively of these parts in terms of n and K. So this probably is having force constant K1, it is having force constant K2. If you are connecting some mass over here and the force due to that mass when I connect this spring together with this length L2 and constant K2, the system is same. Now we can say that these two springs are in series with each other, and for individual springs, for example for upper springs, we can have for the same force is equals to minus of K1 L1, and for this we can have F is equals to minus of K2 L2. Here for same force and for the same mass, the elongation is equals to K minus K L1 L2, L1 plus L2. So see, you can compare, forces are same in all these three cases, but in this case comparing our same force with the total force, so I can say that K L1 plus L2, again the minus of K L1 plus L2 is equals to minus of K1 L1. Now let's solve this. We have a relation L1 is equals to NL2, substitute it. Minus minus sign will be cancelled out. K1 is equals to K into NL2 upon L1 plus L2 upon L1, but again L1 is equals to NL2, substituting it and L2 upon and L2 plus L2 upon and L2 is equals to K1, K into 1 plus L2 L2 cancel, 1 by n, that is equals to K1. Now I obtained relation for K1, that is 1 plus 1 by n k. Similarly, we can compare these force equation with our total force equation like this: minus of k L1 plus L2 is equals to minus of K2 L2. My minus sign will be cancelled out, and we can substitute an expression for L1, that is an L2. So K and L2 plus L2 is equals to K2 L2, and my L2 is equals to K2 is equals to K and L2 upon L2 plus L2 upon L2, that is K n plus 1, that is my K2. Hope you have got it. Next question, fourth question, and in this question we are having an oscillator of mass 100 gram. That means mass is given to us, that is 100 gram, is performing damped oscillation. Its amplitude becomes half of its initial amplitude. Suppose initial amplitude is A, and A at any time t becomes A by 2 when after 100 oscillations. That means in terms of time, if its period is 2 seconds, that means time to complete one oscillation is 2 seconds. So after 100 oscillation, the time passed will be 100 into 2, that is 200 seconds. That is my time. Find damping coefficient. Here we need to find out B. We are having formula for damped oscillation. My amplitude always varies with respect to time. The formula was A at any time t was equals to maximum amplitude into e to the power minus bt by 2m. Now A at any time t is it's becoming A by 2, that is equals to A e raised to minus of bt by 2m. A will be cancelled out. Taking inverse on both the side, I will be getting 2 equals to e raised to bt by 2m. Now taking natural logarithm on both the sides, my exponential will be cancelled out from log. It is plus bt by 2m is equals to natural logarithm of 2, but natural logarithm of 2 is nothing but 2.303 into log 2, that is equals to bt by 2m. Again my log 2 is 0.3010, that is equals to bt by 2m. Now my b equals to 2m, that is 2 into 100 gram into 2.303 into 0.3010 divided by t, that is 200 second. 2 into 100, that is 200, will be cancelled out with this. I'll be getting b equals to 0.693. The unit will be in CGS units. That is dyne second centimeter inverse. Next. Now next question is fifth. Amplitude of an SHO is A when it is at a distance y from the main position of the path of its oscillation. The SHO receives blow in the direction of its motion, which doubles its velocity. Find the new amplitude. Now we know that velocity is equivalent to omega root of a square minus y square. Now this is my general equation. Now when my amplitude is a, my displacement at any point y, my velocity is v. Now at this point y, my velocity is becoming double. What will be its amplitude? Means my velocity is becoming double at some new amplitude but same displacement. So this will be my second equation. Now for comparing these two equation, I should have any one, either LHS or RHS, that should be same. So I'll make LHS same by multiplying 2 on both the sides. Now I can compare my RHS of both the equations, that is 2 omega root of a square minus y square is equivalent to omega root of a1 square minus y square. Squaring on both the sides, I'll be getting 4 omega square a square minus y square is equivalent to omega square a1 square minus y square. Now solving for a1 square, first of all I can cut this. 4a square minus 4y square is equivalent to a1 square minus y square. Taking these y square that side, 4a square minus 4y square plus y square is equal to a1 square. And finally I am having 4a square minus 3y square is equivalent to my new amplitude square, and for my new amplitude I'll be having root of 4a square minus 3y square. Now this is my final answer, 4a square minus 3y square.